Hey everyone, this is another episode of That's Interesting. We have measurement. It is a tool or device. It is it's not a trick, but it's definitely a way to record something to increase the validity of an experiment. We're not getting exact values, but we're going to get an approximation. It's kind of exact. It's approaching there. It's close. We can use volume, we can measure force, we can measure temperature, weight, length, and so on, using these types of units. In fact, there's two different types, metric or imperial. More about that later. Well, not in the video. Countable units, these are natural numbers, but we're using these things in spite of all of these measurements. These are accurate no matter what. You can have half or something like that. Significant digits are used to indicate the measurement of different things. And in fact, if you're wanting to know the certainty, we need to know which numbers or which digits are significant. Non-zeros are significant, we know what they are. Captive zeros, the ones between two real or two known values, those are significant. These values, like 0.0020, they're different in the same way as 1000 or 1000, because those are placeholders. We don't know what these zeros really are. Those are undetermined. There's nothing before or after, it's just like that. But however, this 0 after the 2, this is after a known value. Since we're using a decimal place, we know what that 0 is. If you use like a ruler, you'll figure it out. When adding or subtracting values like this, you can have an estimated answer with the least number of decimal places within the terms. Multiplying or dividing, you need to get the answer must be in the least number of significant digits. So if you have 5 significant digits times 10 significant digits, and then you end up with a number, you have to use 5 significant digits. Rounding down, less than 4. Rounding up, 5 or greater. Scientific notation goes like this. In order to have scale, because we don't want to write a really large number, dimensional analysis is something we can use with measurements. When it comes to rates, rates are a combination of two different measurements. It is a proportion trying to have the change in y over the change in x. So having that down, we can use 2 miles for 1 gallon, and then multiply that by 1 gallon for 4 quarts, and then 5,280 feet in 1 mile. We cancel out the units because conversion factors are 1, basically. We have the same value, and in the same way we cancel out the units to get a new unit or a unit based on the proportion. There we go. With a molar, it is a molecular unit or a molecular measurement dealing with atoms.